Take a small magnet and hold it over a paperclip. The metal leaps up and sticks to it. It is a completely mundane event, but it reveals a glaring physical absurdity. The entire mass of the Earth is pulling down on that paperclip, yet a cheap piece of magnetic metal easily overpowers it. Compared to the other fundamental forces that govern our universe, gravity is an outlier. Electromagnetism, the strong nuclear force, and the weak nuclear force are roughly equal in power. Gravity is a microscopic sliver at the end, a trillion times weaker than the others. For physicists, this imbalance is a glaring problem. The equations that describe how the universe operates suggest that gravity should be just as strong as its counterparts. Since it isn't, our model of reality is missing a crucial piece. Gravity appears to be leaking. This suggests that we might be searching for gravity in the wrong number of dimensions, looking for the full force of nature in a place where only a fraction of it remains. Imagine a water bug skating across a pond. To the bug, the universe consists entirely of the flat, two-dimensional surface tension of the water. It goes about its day, unaware of the depth below, until a fish darts up and eats it. The bug fails to see the predator because it cannot perceive the dimension the fish occupies. Humans may have a similar biological blind spot. Susan Berry was born with severely crossed eyes, causing her brain to discard data from one eye to avoid confusion. For 48 years, she lived in a perfectly flat, two-dimensional world, unable to perceive depth, until intensive vision therapy allowed a third dimension to suddenly pop into her awareness. The philosopher Plato described this condition thousands of years ago. He imagined people chained inside a cave, watching two-dimensional shadows cast by a fire. Because they could not turn around, they mistook those flat silhouettes for the full scope of reality. Our brains evolved to process length, width, and depth. We lack the biological sensors to perceive a fourth direction. However, this inability to see higher dimensions does not prevent them from manipulating the physics of our world. Theoretical physicist Lisa Randall looks at the equations on her chalkboard and sees a specific architecture for these hidden dimensions. Her work focuses on brain theory, a leading model for how extra dimensions interact with our reality. Our universe is a flat brain where visible matter exists as open strings anchored firmly to the surface. But gravitons are closed loops. They lack the mechanism to stick to our universe, drifting freely into a dark void outside our three dimensions. As these gravity loops escape our universe and enter a hidden fourth-dimensional space, the force dilutes. In our world, we only experience the weak tail end of gravity's true power. In this model, the full strength of gravity is concentrated in a parallel dimensional space, separated from us by a fourth-dimensional gap we cannot cross. When we track the motion of entire galaxies, the math breaks again. There is 5 times more gravity holding stars in place than there is visible matter to generate it. This missing mass is what we call dark matter. Physicist Tim Tate theorizes that dark matter consists of regular particles of light, photons, that were blasted into the fourth dimension during the intense heat of the Big Bang. A stationary particle on a flat line seems weightless, but look closely. If that line is actually a cylinder, and the particle is racing around the hidden outside edge at high speed, it generates energy. And in physics, energy equals mass. This suggests the missing weight of the cosmos is an illusion. We are feeling the mass of ancient light, trapped in the unseen geometry of an extra dimension. Across the globe, scientists are building massive machines to act as echolocation, scanning the physical world for the shadows of these extra dimensions. At the University of Washington, Eric Adelberger monitors a delicate torsion balance. He is looking for gravity to behave differently at microscopic scales. If he measures a sudden spike in gravity at a distance smaller than the width of a human hair, he will have located a fourth dimension. Under the Swiss Alps, the Large Hadron Collider takes a more violent approach. Scientists use a 17-mile racetrack to smash subatomic particles together, attempting to force them close enough to physically breach these microscopic hidden dimensions. If the particles are forced close enough, they may tap into the undiluted strength of gravity hiding in the extra dimension. This would create a microscopic black hole that evaporates in a fraction of a second, leaving behind a spray of particles as proof. These experiments represent a massive engineering effort to prove that the 3D reality we inhabit is only a tiny fraction of the actual universe. While physics prepares for a universe of 9 dimensions, physicist Renat Lal suggests a radical alternative. She suspects the search for extra dimensions is moving in the wrong direction entirely. Rather than looking for gravity leaks, Lal uses supercomputers to simulate the organic growth of space from scratch, attempting to find the fundamental shape of reality by building it from its smallest components. In a 3-dimensional space, an ink drop spreads in all directions, but as her simulation zooms into the quantum fabric, the dimensions vanish. The ink flattens out into a 2D plane and then collapses into a single 1-dimensional line. In Lal's simulations, the fabric of space at the absolute lowest quantum level appears as a microscopic mesh made of single 1-dimensional lines. This suggests that the solid 3-dimensional space you are moving through right now is an emergent illusion, woven together out of quantum threads that possess only a single dimension. Physics currently faces a profound choice. To explain the universe, reality must either be a multi-dimensional labyrinth where gravity hides, or a bare 1-dimensional web. From Einstein's discovery that space can warp, to the engineers firing protons beneath the Swiss Alps today, the progress of science requires looking past what our eyes tell us is true. Whether the universe expands into invisible realms or collapses into a single geometric line, the 3D world we experience is a biological interface masking a much stranger truth.